Bonding patterns. These patterns are going to help you tremendously when it comes to organic structures. All you have to do in this case is just remember a quick rule that will guide you toward drawing a structure, and it will help you in formal charges and other topics, subsequent topics. So you need to remember that if based on the valence electrons, in this case, let's say carbon has 4, then it needs 4 more to form the octet, which is 8. The octet rule is you must have 8 valence electrons. So therefore, in this case, the electrons that are needed would be 4 more, and this would result in 4 bonds being formed. So actually, carbon would love to have 4 bonds in order for it to be happy or fill the octet. So here are the 4 electrons. For nitrogen, if it has 5, then it needs 3 more to complete the shell, and that would result in 3 bonds and, of course, an electron pair. Oxygen has 6, so it needs 2 more in order for it to form an octet. So if you notice here, if you count them, you have 8 in total. Each of these lines means 2 electrons. And then the hydrogens and the halogens, and by the way, the halogens are fluorine, chlorine, bromine, and iodine. If you don't remember, these need 8 electrons, but they have 7 for the halogens, so they need only 1 bond, and so is hydrogen because it only needs 2. Okay, so here's the rule to remember. And by the way, I'm going to say this before. This applies if you read this word here for neutral compounds. So neutral, only neutral, meaning there are no charges, neutral molecules. Quickly, write down this. HONC 1, 2, 3, 4. Okay, so what does the H stand for? That stands for hydrogen. And what else that has an H? Halogen. Well, the H in this case, whether it's hydrogen or halogen, needs 1 bond. So 1 bond. The O, what do you think that is? Oxygen. Oops. Delete this for a second. Bear with me. Oh, I deleted the... That requires 2 bonds. The N, you guessed it by now, that's nitrogen. Requires what? 3 bonds. Three bonds. And then, of course, finally is carbon, which requires 4 bonds. Now, this will help you when you draw molecules to determine how many bonds you need. So, give you a quick example is if I have, for example, something as simple as ammonia, NH3. Now, I'm going to say based on HONC, or sometimes it's pronounced honk 1, 2, 3, 4, like honk the horn. This would require N to have 3 bonds. So you say, okay, N is in the middle and it has 3 bonds. Now, if you recall the octet rule, you have to have 8. So far we have 6, 2, 4, 6. Remember each line, and I'm going to show them for this time only. Each line means 2. So it means that it's actually missing two more. And where would they come from? Well, they would come from a lone pair. So anytime you don't have enough electrons in those bonds, at least again, for neutral molecule, I'm saying, then you use the lone pairs to compensate for that. So here's water also. Water, you know, oxygen is in the middle because hydrogen only has one bond. So you attach it like this. Well, we need to compensate. So we add, of course, the two electrons. So this is how you're going to develop the patterns. And you will see them as we move on.